So, did a human write this? Or did an AI? Honestly, it's kind of the defining mystery of our modern digital age. Every single time you read an article or an email, or even a piece of code today, there's a very real chance you're interacting with a machine that's just pretending to be human. Today, I want you to play detective with me. We are going to look right under the hood of the technology that started this whole thing and explore the incredibly high-stakes arms race of spotting modern AI text.
Welcome to this explainer. I am so excited to guide you through this today because we're unpacking some truly fascinating source material from Amon's AI journal. We'll be fully demystifying ChatGPT, tracing its wild evolution from simple next word prediction all the way to the complex, sophisticated systems that are desperately trying to detect it today.
Here is our quick roadmap for today. We're going to break this down into 4 key areas. First, beyond next word prediction. Second, the power of human feedback. Third, something called the alignment tax. And finally, spotting the bot.
Okay, let's dive into Chapter 1, Beyond Next Word Prediction.
To really appreciate where we are right now, we have to look back at the fundamental problem with older AI models. Take GPT-3, for example. It was, honestly, kind of like a reckless, giant autocomplete. It used the decoder part of a transformer architecture just to guess the next word based on whatever it scraped from the internet. And because of that, well, it frequently offered false or even hurtful information. Now, consider the new way. ChatGPT is fundamentally different because it was explicitly focused on multi-round conversational dialogue. And most importantly, it's actually aligned with what users want and need.
20 billion. Just think about that number for a second. That is the confirmed parameter count of ChatGPT 3.5. Now, while earlier rumors suggested these models had to be astronomically huge to even function, OpenAI actually did a masterful job distilling and compressing the model down. So the absolute crucial takeaway here is this: raw model size ultimately doesn't matter nearly as much as the quality and the diversity of the data you feed it.
Moving right along to Chapter 2, the power of human feedback.
Okay, so we know the earlier AI was basically a wild autocomplete machine. So how did developers actually tame it? Well, they use something called RLHF. That stands for Reinforcement Learning from Human Feedback. Think of RLHF as the AI steering wheel. Instead of just letting the machine learn passively from random internet text, developers literally put human trainers into the loop to rank the machine's responses. This method actively minimizes harmful, untruthful, and biased outputs. It aligns the machine with actual human intent.
So, how exactly does this steering wheel work in practice? The process, which was primarily pioneered on ChatGPT's sibling, InstructGPT, involves this brilliant 3-step dance. Step 1 is supervised learning. Here, developers fed the AI about 13,000 highly curated instruction output samples just to demonstrate desired behavior. Step 2 is the reward model. Trainers took 33,000 AI outputs and ranked them from best to worst, which basically teaches a secondary model exactly what humans prefer. And finally, Step 3 uses reinforcement learning. They took 31,000 fresh prompts and updated the AI's policy using a pretty complex math process called proximal policy optimization, all based on those human preferences.
The results of this human-in-the-loop training, they are absolutely staggering. Listen to this fascinating quote from OpenAI. Our labelists prefer outputs from our 1.3B InstructGPT model over outputs from a 175B GPT-3 model, despite having more than 100x fewer parameters. Wow. By simply teaching the AI to behave nicely and follow instructions, a tiny, aligned model was able to vastly outperform a model more than 100 times its size.
Which brings us to Chapter 3, the alignment tax.
Now, teaching an AI to be perfectly safe and polite sounds amazing, right? Well, there's a catch. It's known as the alignment tax, or sometimes researchers call it negative transfer. By forcing the language model to focus so heavily on safety and following conversational rules, it actually gets worse at certain specialized tasks. Researchers noticed real performance regressions on public natural language processing tasks. Things like specific reading comprehension tests, common sense reasoning, and even French to English translation.
You know the old saying, there is no free lunch? Well, that is absolutely true in AI training. Everything is a trade-off. If you want a perfectly safe, highly conversational AI, you might just lose some raw technical performance. One really fascinating workaround that researchers suggest is moving away from having one massive do-it-all model. Instead, we could use several smaller, specialized models that excel at very narrow tasks without ever having to pay that alignment tax.
All right, our final chapter, Spotting the Bot. We've seen how they train it, and we've seen how they make it talk so much like us. So how do we actually catch this perfectly aligned AI in the act of writing? Right now, there is an absolute arms race happening in AI detection. We're seeing tools like watermarking, DetectGPT, OpenAI's own AI classifier, and GPT-0. Let's break down how these actually work.
First up is watermarking. I know we're not talking about a visible, semi-transparent stamp on a piece of paper. In the AI world, a watermark is a completely unnoticeable cryptography-based secret signal that is fundamentally baked right into the choice of words by the language model. The idea here is that an AI company would weave this hidden mathematical signature into the text. That makes it incredibly easy for software to spot its origin, but it doesn't change the meaning of the sentence for the human reader at all.
Next, we have a really clever tool called DetectGPT, and it relies on the underlying probabilities of words. See, if an AI writes a sentence, it chooses words based on high probability. DetectGPT takes that sentence and perturbs it, which is just a fancy way of saying it swaps out some of the words. If the new, modified sentence has a noticeably lower probability score than the original, it means the original was perfectly optimized. Ergo, it was AI-generated. If the scores are roughly the same, well, a human probably wrote it.
But there is a massive catch. DetectGPT has a pretty huge limitation. To calculate those complex math scores, you literally have to have access to the exact AI model that generated the text in the first place. If you're a teacher trying to analyze a student's essay, you probably have no clue if they use ChatGPT or a specialized local model or something entirely different. And without knowing the exact model, the math completely falls apart.
That brings us to another famous tool, GPT-0. This one relies on a metric called perplexity. Let's just strip away the jargon for a sec. Perplexity is basically just a measure of how random or predictable text is. Remember, AI models are trained to maximize predictability. So if a text has very low perplexity, meaning it's extremely predictable and not random at all, GPT-0 points its finger straight at a bot. Human writing is naturally a bit more messy, a bit more varied, and, well, a lot more perplexing.
So, to summarize the current landscape, the crucial point is that while our tools are very clever, none of them are perfect. DetectGPT needs access to the specific model. OpenAI's own AI classifier only gives a vague probability score. It mostly just classifies things as unlikely or unclear. And GPT-0 can only approximate those perplexity values using a linear model, which means, yeah, it can absolutely be fooled.
Which leaves us with this final, kind of lingering thought. As we've seen throughout this explainer, these AI models are becoming smaller, they're becoming far more efficient, and they're incredibly well aligned to mimic human intent and conversation perfectly. The line between human and machine text is literally blurring by the day. So, as these models continue to shrink in size but grow in alignment, will we ever truly be able to detect the bot among us, or is the arms race already over? Thank you so much for joining me to explore this fascinating topic today. Keep questioning what you read out there and keep learning.